Hello, chemistry. Mr. McKee here, and today I want to talk to you about different types of chemical reactions and recognizing the equations that describe these reactions. This will be a pretty short video. If you want to follow along in the booklet with the examples I'm going to go over, we are on page 26. So there's three basic forms of equations that we're going to learn about. We've seen this first one, which is combustion equations. And the thing you want to look for with combustion equations is this part right here is always going to be the same. You're always going to have oxygen as one of the reactants, and you're going to have carbon dioxide and water as the products always. The coefficients can change, but the basic chemicals do not change. The other thing that changes, of course, all the time is the exact identity of this carbon compound here. Okay, examples of combustion reactions. This occurs in a car's engine. This occurs in cellular respiration, basically, which is how organisms get their energy. And this is what powers your gas grill, your gas oven at home if you have one of those. And this is what also heats your hands if you're sitting around a campfire. Okay, synthesis equations are very simple. To synthesize something means to build something, and in this case, we're taking two smaller parts. These could be atoms or ions, and they're going to combine into a compound, AB. So the basic form is A plus B makes AB. We'll see examples of that here shortly. Decomposition is the exact opposite of synthesis. To decompose means to break apart. So in this case, we start with a compound, AB, and it is going to split into A and B, which will be separate from each other. So let's get into a few of the examples here very quickly. And you'll notice that we're going to continue to practice balancing equations in this section. As I've said many times, repetition is the key to getting good at balancing equations. So check out this particular equation here. You'll see that we've got one part, the zinc, joining with another part, the bromine, and they are forming a compound, zinc bromide, on the other side. So A plus B makes AB. This is a synthesis equation. Now in this case, and this will be the case sometimes, the equation is already balanced for you, so we don't need to add any coefficients in order to balance this. So if you want to go through the steps here, you would do this, and we have two bromines and one zinc on each side of the equation. Again, that's a synthesis reaction. Next reaction, hopefully you recognize quickly here. This part, we have oxygen as a reactant and carbon dioxide and water as the products, typical of a combustion reaction. This particular combustion reaction is for octane, which is one of the hydrocarbons that is found in gasoline. So this is a chemical reaction that occurs in your automobile, the internal combustion engine. All right, so balancing this might be a little bit trickier here because we have an even number of carbons. So the thing that stands out to me is the 8 carbons on the left and only 1 on the right. So I'm going to start by putting an 8 there. Then we have 18 hydrogens on the left and only 2 on the right. So I'm going to put a 9 there. And this is going to give me an odd number of oxygens, which is always tricky. So I have 16 oxygens contributed there. And I have 9 contributed there for a total of 25. So I need to come up with a coefficient that when multiplied by 2 is going to give me 25. And there's, of course, no whole number that will do that, but I'm going to temporarily put a decimal here. 12.5 oxygens. And, of course, we have one of those compounds right there. And that gives us a balanced equation. But as I said, we have to use whole numbers in order to balance this. So the solution is we're going to multiply all these coefficients by 2. that's going to preserve the ratio, but it's going to get rid of the decimals. So this 1 becomes a 2. This 12.5 is going to become a 25. This 8 becomes a 16. And this 9 becomes an 18. And now, using those coefficients, we have a balanced equation with whole numbers. And you can check your work down below. We've got CHO on both sides, carbon, hydrogen, and oxygen. And we've got 16 carbons on both sides. We've got 36 hydrogens. And we have 50 oxygens on both sides. Okay, last example. Let's look at the form here. We start with a compound. We can call it AB. And it's breaking apart into A plus B, individual components there. And of course, this is a decomposition reaction. And let's see what we need to do to balance it. The difference between the two sides that stands out is this 2 in front of the chlorine. So I'm going to put a 2 to equalize that. That creates an imbalance with my sodium. So I'm going to have to put a 2 there. And let's go ahead and double check our totals down below. We have 2 sodiums and 2 chlorines on each side, so we are indeed balanced. So that's the first 3 of the types of equations that we need to know. We're going to add 2 to this tomorrow, but start with just these 3. As always, reach out if you have any questions. Have a great day.
Can I sit here and study?